Welcome to the deep dive. We know you're looking to get up to speed quickly on some pretty specific tech tools.
Yeah, the really niche stuff.
Exactly. And today, we're diving into a piece of AV gear that solves a very particular but often critical problem. It's the A-Neuvideo ANI-HDAINSERT4k6. It's a 4K60 HDMI audio inserter.
Right.
So our goal here is to unpack what it does, its core job, but also why its specific features are, well, pretty essential in more complex AV setups.
Okay, so fundamentally, this device, it's basically acting as a bridge, when you've got separate audio and video paths.
Right, like your video source is set, maybe a computer output or some specialized camera feed.
Yeah, exactly. But the audio needs to come from somewhere else, maybe a high-end mixer or a dedicated audio player, something like that. So this inserter grabs that external audio, merges it into the video stream, and then spits out a brand new HDMI signal with your custom audio baked in.
And looking at the inputs, it's got flexibility. I see analog stereo, the standard RCA jacks, but also digital SPDIF. That seems pretty deliberate. It means it can connect to, well, almost anything audio-wise, right? Old school analog or newer digital.
That's the key for integration, really. Handling both analog line level and SPDIF covers most bases you'd encounter. And then on the output side, it's not just jamming any audio in.
Okay.
It can insert standard stereo, LPCM 2.0, or even multi-channel bitstream audio. Depends what the next device in the chain needs to see.
And crucially, especially for pro environments, you're not losing quality in the process. I was reading, it looks like this thing supports pass-through for really high-fidelity audio formats.
Oh yeah, things like LPCM 7.1, the various bitstream formats, even HD bitstream. And it maintains high sampling rates too, up to 192 kilohertz for both the HDMI audio it's passing through and the SPDIF input.
Wow, okay, so 192 kilohertz, that's pretty serious fidelity, studio level almost.
It basically guarantees that if you already have high-res audio in your original HDMI signal, like uncompressed 7.1 or something, it just passes right through, untouched. But you still get the option to inject your own audio signal over it if you need to. It keeps that end-to-end signal integrity.
Okay, so audio insertion handled, fidelity maintained. Let's talk video, because carrying all this needs serious bandwidth, especially at 4K.
Absolutely. This isn't just standard HD we're talking about. To keep the picture quality pristine, it handles 4K UHD resolutions all the way up to 4K at 60 Hz. And importantly, with 4.4.4 chroma subsampling at 8-bit color.
Right, that 4.4.4 is the key, isn't it? No color compression. What you put in is what you get out, visually speaking.
Exactly. No weird color fringing or loss of detail you sometimes get with lower bandwidth 4.2.2 or 4.2.0 signals. And it does this because it runs at the full 18 gigabits per second HDMI bandwidth. That's 600 megahertz.
Maxing out the spec. And for plugging it into systems, compliance is always huge. It handles HDCP, right? Both versions.
Yep, HDCP 1.4 and the current 2.2. So it works with older and newer sources and displays. It even technically supports DVI 1.0 if you use an adapter.
Okay. And I noticed something else important for certain buyers, TAA compliance.
Ah, yes. That's a big deal for government contracts or certain institutional purchases.
It means it's approved for those specific procurement channels where, origin and supply chain security matter.
Precisely. It tells you it's not just some off-the-shelf consumer box. It's built and sourced for more demanding, regulated environments.
Okay, let's shift gears slightly. High bandwidth, check. Compliance, check. The next big headache in these systems is usually stability, right? Getting everything to talk nicely.
Oh, definitely. The dreaded handshake issues.
Which is where EDID management comes in. Explain that a bit. Why is controlling this extended display identification data so vital with 4K?
So EDI is basically the signal's business card. The display tells the source, here's what I can handle: resolutions, refresh rates, audio formats. The source reads that and sends an appropriate signal.
Simple enough, sounds like.
In theory. But when you start adding devices in the middle, like an inserter or using splitters, extenders, that conversation can get confused.
Yeah.
The source might get bad info or no info, and then defaults to a basic safe signal like 1080p, or you get no picture at all.
Ah, okay. So this device lets you manage that conversation.
Exactly. It has several built-in EDIDs you can choose from. You can tell it to just pass through the ED from the final display. Or, and this is powerful, it has 2 user slots where you can load your own custom EDID files.
So you can basically force the source device to output exactly the format you need, even if the display is being difficult or the chain is confusing things.
Pretty much. You override the negotiation and enforce stability. It prevents those cascade failures you see in big video walls or complex distribution systems. That's absolutely critical.
Makes sense. And I see it also has RS-232 control.
Well, RS-232 style control, yeah. It uses a virtual COM port over its USB connection, so system integrators can script it, control it remotely, integrate it into larger automation systems.
Got it. And physically, it looks pretty standard, sturdy metal box, fairly compact.
Yeah, about 5 by 1 by 4¼ inches, solid build. And it comes with a 3-year warranty, which is decent for pro gear.
So, wrapping it up, the ANI-HDAINSERT4k6, it's clearly more than just a simple audio inserter. It's really a high-bandwidth signal management tool, a central piece for complex 4K setups where you need both audio flexibility and rock-solid video signal control.
Right. It handles the full 18 GBPs, does the HDCP dance, gives you that crucial EDID control, and inserts your audio cleanly.
Which leaves us with a final thought for you, the listener.
Consider this. If even a device focused primarily on audio insertion needs such robust video capabilities, like the full 18 gig bandwidth and deep EDE control, what does that reveal about the inherent challenges, maybe even fragility, of managing modern, high-resolution AV signal chains in the real world? It suggests that just meeting the specs isn't always enough. Sometimes you really need the power to take control and stabilize that whole digital pathway yourself.